Welcome to this new chapter about operators. What are operators? An operator is a symbol that gives us the possibility to perform mathematical and logical operations. And we will see 5 types of operators. Arithmetic operators, to perform arithmetic operations like the addition and the subtraction. Relational operators, to be able to compare between values. Logical operators, to be able to create Boolean expressions. Assignment operators, to be able to modify the value of a variable with different ways, and finally, bitwise operators to perform bit-level operations. So see you in the next video to start with the arithmetic operators. Welcome to this video where we will talk about the arithmetic operators. As I said in the precedent video, the arithmetic operators are used to perform arithmetic operations. We can calculate the sum, the difference, the product, the quotient, and the remainder. Let's start with the first arithmetic operator, which is the addition operator. The addition operator is represented by the plus symbol. It's a binary operator because it needs 2 elements, one from the left and one from the right, and it returns the sum of those 2 elements. For example, we have 2 variables a and b of type int initialized to 10 and 8 respectively, and if we create a third variable named c, for example, and we initialize it to a plus b, and we print its value, we can see that it's 18, because a plus b returns the sum of the value of the variable a and the value of the variable b, which is 18. This one isn't hard to understand, I think, and by this way we can do the addition of more than 2 elements. For example, in the variable c, we can initialize it to a plus b plus 15, for example, so c will have the value 33, because a plus b plus 15 is equal to 33. Now, second arithmetic operator, the subtraction operator, represented by the minus symbol. Same thing here, it's a binary operator. We need an element from the left and one from the right, and it will return the difference between them. So the order here is important, because the subtraction isn't associative. Let's do an example. Let's use the same variables a, b, and c we worked with in addition. But now, instead of assigning the addition of a and b, we will replace the plus sign by the minus sign. So now, the value of c is 2, because a minus b returns 10 minus 8, which is 2. Addition and subtraction are basic operations that you should know if you ever did some basic math. Now let's move to multiplication. Multiplication is represented by an asterisk, this symbol. It works as same as addition and subtraction. We have 2 elements and it returns their multiplication. So if we do it with our variables a and b and we assign the value to c, we get c is equal to 80, because 10 multiplied by 8 is 80. But note that you can't do the multiplication by sticking a and b to each other like in maths. Same thing for the point. You can't do a multiplication of 2 variables by putting a point between them like in maths. In C language you have to put the asterisk. Let's move to the fourth arithmetic operator, the division operator. The division operator is represented by the slash symbol, and it returns the result of the division of the left element by the right element. But the result depends on the data type of the elements. If at least one of them is a floating point number, so it's of type float or double or long double, we will get the full result of the division. So for example, if we divide 7 by 2, we get 3.5. But if both of them are integers, we will get an integer as a result, which is the quotient of the division. So if we divide 7 by 2, we get 3, which is the quotient, except if we do a typecasting, as we will see in the next video. Now let's see 2 examples about it. If we hold the same variables a, b, c with a is equal to 10 and b is equal to 8, here they are both integers. So if we calculate the division of a by b, we get the quotient, which is 1 in this case. But if we change at least one of them to a floating point number, we get 1.25. Last arithmetic operator we're gonna see is the modulus operator. This one can be new to you because you may not seen it before like the other ones. The modulus operator is represented by the percentage symbol. But what does this operator do? This operator returns the remainder of the Euclidean division of the left element by the right element. For example, I have 8 candies that I want to share with 3 kids. Each kid can take up to 2 candies, and I have 2 candies left that I can divide by 3. This is the remainder. Other examples, the remainder of 11 by 4 is 3. The remainder of 8 by 2 is 0. The remainder of 7 by 3 is 1. The remainder of 9 by 2 is 1. Note that we can use the modulus operator only with integers. We can do it with floating point numbers. And also, the remainder is always greater or equal to 0 and smaller than the divisor. The remainder is useful, for example, to determine if a number is even or odd. Because if a number modulus 2 returns 0, it means that the number is even, and if it returns 1, it means that the number is odd. And to take up our example of ABC, if we assign to C the operation A modulus B, we get that C is equal to 2, because 10 modulus 8 is 2. See you in the next video to talk about typecasting. Welcome to this video where we will talk about typecasting. In previous videos we performed operations on variables of the same type. But what if we want, for example, to add a variable of type int with a variable of type float? In that case, one of them will be converted to the other one's data type. And we have two types of conversion. We have the implicit conversion. This one is performed automatically by the compiler, so we don't have to add additional code for it. But which one will be converted to the other? You have to know that the small data type will be converted to the higher one by following this structure. So for example, if we have in the operation a float and an int, the int will be converted to float. This is what we call a type promotion. It doesn't do the opposite because it can cause data loss. But even type promotion can cause data loss. For example, by following the data type structure, a variable of type long int will be converted to float. But long int can hold 8 bytes, while float can hold only 4, so be careful about this. Here is an example. We have a of type int and equals to 4 and b of type float and equals to 5.5. If we do the addition, a will be converted to float and it becomes 4.0, so the addition gives 9.5. Second example, we have a of type int and equals to 10 and ch of type char and equals to uppercase A. If we do the addition, ch will be converted to int and its value is the ASCII value of uppercase A, which is 65. So the addition will be 10 plus 65, which is 75. It can be useful, for example, in a program to get the next letter by adding 1 to the actual value of the character. Here is an example. Second type of typecasting is the explicit conversion. We will choose the data type by ourselves, so we don't have to follow the structure. For that, we add the data type that we want to convert to between parentheses before the variable. For example, we have the variable a as int and equals to 5. If we want to get its value converted to float while printing, we add float data type before it like this. So we get 5.0s. We can also do the opposite way. For example, we have a variable b of type float that equals to 7.5. If we want to print its value converted to int, we write int before it like this, and we get 7. And as said earlier, typecasting can lead to data loss, so be careful when using it. See you in the next video to talk about relational operators. Welcome to this video where we will talk about relational operators. Relational operators are binary operators that gives us the possibility to compare between two values. For example, by using them we can know if two values are equal or if one is greater than the other. Before starting, you have to know that a relational operations returns a boolean value. It returns 1 if the relation is true and 0 if the relation is false. Let's start with the equality operator. The equality operator is represented by two equal signs. You have to differentiate it with the assignment operator that we use to give a value to a variable. So the equality operation returns true if the compared elements have the same value and false in the other case. For example, if we print the result of 5 is equal to 5, we get 1. Because 5 is equal to 5 returns true, so we get 1. But if we print the result of 3 is equal to 6, we get 0. Because 3 is equal to 6 returns false. We can also compare variables. For example, here we have the variables a and b initialized to 6 and 6 respectively. If we use the equal operator, we get true, because the value of a is equal to the value of b. Now let's move to the second relational operator, which is the opposite of the first one. It's the non-equal operator. It's represented by an exclamation point directly followed by an equal sign, and as you guessed, it returns true when the two compared values are different, and it returns false when the two compared values are equal. So if we take back our last example where a is equal to 6 and same thing for b, and we print the result returned by the non-equal operator, we get false, because a and b have the same values. But if we change the value of one of them to 10 for example and we compile again, we get true, because a and b aren't equal anymore. So the non-equal operator returns true. Third operator, we have the greater than operator. It's represented by this symbol. This one returns true only if the left element is strictly greater than the right one. It means that if the left element is equal to the right one or smaller than him, it returns false. If we take our last example and we print the result of a is superior than b, we get true because 10 is greater than 6. Next operator is the smaller than operator. It's represented by this symbol. This one is the opposite of the precedent one. This one returns true only if the element is strictly smaller than the right one. So if it's equal or greater than the right one, it returns false. So if we try it in our last example, a is smaller than b returns false, because 10 isn't smaller than 6. But if we change the value of a to 3 for example, and we compile again, we get true. Next operator is the greater than or equal to operator. It's represented by this symbol. Greater than symbol followed by an equal sign. This one looks like the greater than operator, but the difference is that this one returns true when the two compared values are equal. This is why it's called greater than or equal to. So it returns false only when the left element is strictly smaller than the right one. Here is the proof with these three results. Last relational operator is the smaller than or equal to. It's represented by this symbol. Smaller than symbol followed by an equal sign. You would have guessed this one returns true when the left element is smaller than or equal to the right one, so it returns false only when it's strictly greater, as we can see in these examples. Now here is a lot of examples to better understand the relational operators. You can find it in the resources of this lecture. See you in the next video to talk about the logical operators. Welcome to this video where we will talk about the logical operators. In precedent videos we talk about the concept of a Boolean statement which can be either true or false. But what if we want to verify that two Boolean statements are true at the same time, or at least one of them? This is why we need logical operators. We have three logical operators. Let's start with the first one. The first one is the NOT operator. The logical NOT. It's represented by an exclamation point. It's a unary operator, so it needs only one element, not more. And this operator reverses the logical state of its element, of its operand. So for example, if we have a true statement and we add the NOT operator before it, the operation will return false. And vice versa, if the statement is false and we add the NOT operator before, the operation returns true. For example, let's create a Boolean variable. Don't forget to include stdbool .h. And in this Boolean variable, we will store the result of this Boolean statement. 3 is greater than 2. We know that this statement is true, right? But now if we add the NOT operator before our statement and we print, we get 0, so it's false. Note that the NOT operator comes before the statement and not after. And don't forget the parenthesis except if it's a variable. Second logical operator, the AND operator, the logical AND. It's represented by two ampersands like this. This one is a binary operator because it needs two elements, one from the left and one from the right. And this operation returns true only if both elements are true. This is why it's called AND. Let's see an example. Let's print the result of this logical operation. 10 is greater than 5 and 6 is greater than 4. We get true because both statements are true. But if at least one of them was false like here, we would get false. By this operator, we can for example verify if a number num is greater than 0 and smaller than 100 at the same time. So we have our variable num of type int that we initialize on 55 for example. And in the logical operation we put num is greater than 0 and num is smaller than 100. We can see that the result is true, because the value of num respects both conditions. But if we change num to 120, for example, we get false, because the second condition isn't respected, so we get false. We can also verify more statements that they are all true, not only two. We can do that by putting an AND operator between each two statements. For example, if we have 4 Boolean variables a, b, c, d, and we want to verify that they are all true, so we write a, then AND operator, then b, then AND operator, then c, then AND operator, then d. And this expression returns true only if a, b, c, d are true, all of them. So what's gonna happen here? The machine will evaluate statement by statement. If it finds a false one, it directly returns false, without even evaluating the remaining ones. Now let's move to the last logical operator, which is the OR operator. It's represented by two vertical bars. If you're using a PC keyboard, you can find the vertical bar by pressing Alt+Gr+6. The OR operator is a binary operator. It returns true when at least one of the elements is true. So it returns false only when all the elements are false. For example, if we evaluate this expression, we get true, even if the last statement is false, because the right one is true and it's enough, because we need at least one true statement. So the OR operator returns true when the left statement is true, or when the right statement is true, or both of them, and it returns false when both of them are false. It's an inclusive OR. This is why we accept the case when both of them are true, not like in the English language. We can evaluate more than two statements as we did with AND operator. For that, we put an OR operator between each two statements. So the machine will evaluate statement by statement and will return true when it finds a true statement because it's enough. And now we've seen the three logical statements, so we can make combinations with them. For example, we have two Boolean variables a and b, and we want to verify that only one of them is true, not both. We have two possible cases. Either a is true and b is false, or a is false and b is true. In code we write a and not b, or not a and b. Parentheses are important here, so the whole expression is true when only one of them is true. Before moving to the next video, I want to let you know that if you are interested in knowing more about Boolean logic, I made a whole course about the subject available in Udemy and Skillshare. Now let's move to the next video to talk about the assignment operators. Welcome to this video where we will talk about assignment operators. Assignment operators are operators that are used to assign a new value to the variable. Let's start with the most basic one that we used before, the assignment operator. It's represented by a single equal sign. In the left side we have the variable and in the right side we have the value. So for example, if we execute this instruction, the variable a will have the value 5. So we assigned 5 to a. We can also do it with a variable. For example, we create a variable b, then we assign a to b. So after executing this instruction, b will have the value of a, which is 5. We can even do it with operators inside. For example, here we create a variable c and we assign a plus b. So here c will get the value of a plus b, which is 5 plus 5, which is 10. Now imagine that we want to add a value to our variable. For example, we have a variable a and we want to add 5 to it. The first solution is to write a is equal to a plus 5. It seems confusing, but note that the value of a doesn't change until the end of the instruction, so we can use it in the right side. And here the value of a will increase by 5. But we have an assignment operator that we can use instead of rewriting the variable. It's this operator, represented by a plus sign directly followed by an equal sign. So from the left we have the variable, and from the right we have the value that we want to add to it. To take our last example, we can directly write a plus equal 5, and the value a will increase by 5. So writing variable plus equal value is the same as writing variable equal to variable plus value. And we can do the same thing with subtraction, multiplication, division, and modulus. We write the arithmetic operator followed by the equal sign, then the value. For example, we have the variable b that is equal to 3. If we want to multiply it by 6, for example, we write it like this. After the execution, the value of b will be 3 multiplied by 6, which is 18. If we want, for example, divide the variable c by 2, we would write this. You can try your own examples to better understand how does it work. We have also the increment and decrement operators. If we want to increment a variable, which means adding 1 to it, we can use variable equal to variable plus 1. You can also use variable plus equal 1, but the best and shorter way to do it is to use the increment operator by writing plus plus beside the variable. That's it. We can write plus plus before the variable, or we can do it after the variable. They both will increment a value, but we will see the difference between them in the next video. Same thing for the decrement operator. Instead of writing variable minus equal 1, we can write variable minus minus or minus minus variable. And as said earlier, we will see the difference in the next video. See you there. Welcome to this video where we will talk about the difference between a++ and ++a. If you remember, in the precedent video I said a++ and ++a both increment the variable, but now we will see the difference between them. First, you have to know that they both return a value, so we can write, for example, b equal to a++ or b equal to ++a. But what will be the value of b in each case? In this instruction we have two happening actions. We have the incrementation of a and we have the value return, the assignment. The difference between a++ and ++a is that in a++ the value is returned before the incrementation. So it returns the value, then it increments the value of a. In other words, the assignment happens, then the incrementation happens. It's like we're writing this. This is what we call a post-incrementation. And in ++a, the value is returned after the incrementation. So it increments the value of a, then it returns the value. In other words, the incrementation happens, then the assignment happens. It's like we're writing this. This is what we call a pre-incrementation. It will be clearer with examples. For example, we have a variable a initialized to 5. Now we assign a++ to b, and we print both of them. We get a is equal to 6 because we incremented its value, and we get b is equal to 5 because a++ first returned the value of a, which was 5, then it incremented it. This is why we got b is equal to 5, because it received the value of a before getting incremented. Because at the moment of assignment, a wasn't incremented yet, so it was still 5. But if we use ++a and we print, we get a is equal to 6 and b is equal to 6, because here we incremented a, then we assigned the value to b, which became also 6. Second example, we have a initialized to 8. If we print a++, now we get a is equal to 8. But don't forget that it got incremented after it, so it's 9 now. And if we print ++a after it, we get 10, because we incremented a again. So it became 10, then we printed the value. And this process is the same for a and -a. A returns the value, then it decrements a, post-decrementation, and -a decrements a, then it returns the value, pre-decrementation. I hope you understood. See you in the next video to talk about bitwise operators.